Hi folks, we're back here at Griffith Observatory. I'm David, and I'm here with Keri and Ashwin from JPL, and they're both part of the rover projects that are at Mars right now. We have a pair of rovers that are still operating, and if we can switch over to laptop now, we'll take a look at the first rover we're going to talk about tonight is Opportunity. And Keri, when did we send Opportunity to Mars?
So Opportunity was sent to Mars in 2003, landed in early 2004, was only supposed to last 90 days, or sols, Martian days. We have gone past Sol 5000 at this point, so
Wow.
we've gotten a good return for bang for our buck.
That's pretty good. What was the goal of the mission? What was the whole point of sending it?
Yeah. So Opportunity also had a twin sister Spirit, and both of them were sent to Mars essentially to figure out what is this past story of water on Mars, and could water have been there in such a way that like life could have potentially formed or something like that. So little robot geologists.
Now were they sent to look for signs of life itself?
Just if conditions were right.
Okay.
If there was water or anything like that. It's still really hard to prove a negative on whether there was life on Mars or not. So,
Right.
maybe a future mission will look into that.
Sure. Now, Opportunity and Spirit landed in a very interesting way, I know, that they came in and had airbags and bounced on the ground, but Opportunity kind of did something special.
Yep. So Opportunity essentially did an interplanetary hole-in-one and landed in a little tiny crater that actually had bedrock available. And so she got to roll right out and basically complete her entire science goals in like a few days.
Yeah, it was quite amazing. It was, Eagle Crater, they named it, like getting an eagle in golf. But we shot a hole-in-one from Earth to Mars, which kudos JPL, very well done. But anyway, but you said Spirit, another rover was sent there. What happened to Spirit?
So unfortunately, Spirit got stuck in a sand trap in 2010. So, still plenty of time past her regular life. And unfortunately, we stopped hearing from her in 2010.
Yeah, and one of the last places Spirit visited, I know Spirit had a wheel that was being dragged, but dragged it right across and exposed some salts and signs that there was water there and maybe even a hot spring, if I'm remembering right.
Yeah, so with this stuck wheel, we essentially were dragging the ground and essentially making a trench. And we just happened to look back and see that the trench was white and not red like the rest of the dust. And so we went back and looked and found all of these evidence of silicas and basically that area used to be a hot spring at some point in the past.
Now, hot springs are pretty interesting places. We know here on Earth, hot spring environments can have a lot of life, a lot of extremophiles. So this potentially could be a place in the ancient past of Mars, billions of years ago. There could have been life at this location, perhaps.
Potentially.
Potentially.
Be
so
cool.
We need to look. Now, Opportunity, unlike Spirit, is still, well, we're hoping. Up until recently, we were still communicating with Opportunity, but something has happened here, and we'll take a look at our next slide here. We can go forward one. And what are we looking at here?
All right. So back when I was in school, I studied the Martian atmosphere. And in particular, I studied something called tau, or optical depth. And the reason we call it tau is because that's what you're solving for in the equation. And essentially, it is a measure of direct light from the sun hitting the rover, and thus a solar-powered rover giving you how much power you're going to have. And so in the increments here, the brightest one is 1, and then you go down. So 1, 3, 5, 7, 9, 11. And the last measurement that we had from Opportunity before we stopped talking to her was 10.8.
Now, this is because a giant dust storm has encircled Mars.
Yeah, so
No.
this global dust storm essentially kicked up enough dust around Opportunity that we were essentially the sun is almost blocked out, and you can imagine that's not really good for a solar-powered rover. And so unfortunately she slipped into her low-power fault mode and has gone silent. But we're quite hopeful that once the sun comes out again, that she didn't get too cold and that she'll talk to us again.
Yeah, now what happens with that? Do we need to send a signal, or will she wake up on her own?
So hopefully she will wake up on her own and send us a signal to Earth and say, guys, something happened. I don't know. Help me. And then we're constantly, trying to listen with the Deep Space Network of trying to figure out, is she there? When is she talking to us? And once we hear that signal, then we'll be able to figure out what kind of fault mode she's in.
Okay.
And then be able to respond from there and get her back. And at this point, we've been making a lot of like Schrodinger's cat kind of jokes. We don't know what the state of the rover is until we observe it.
Right.
So we're going to find out hopefully pretty soon, I hope.
Now, I read recently that there's a little bit of hope that some folks have done some simulations and think there maybe Opportunity can weather this storm, but how much longer? Is there a time limit to this?
At this point, we really don't think that she got cold enough that anything would break. Dust storms essentially act like a big blanket, so it doesn't get as cold at night. It doesn't get as warm during the day, but more importantly, it doesn't get as cold at night. And our simulations show that even if there's absolutely no sunlight, that it wouldn't get cold enough at night for any of her parts to break or even come close to their breaking point. So we really do think that she'll come back at the end. It's just a waiting game.
Well, that's great news, because she was seeing some interesting things right before this dust storm came in. There were these weird rocks that formed sort of lines along Perseverance Valley that she's heading down in. And those are seen on Mauna Kea, where there's a lot of freezing and there's water in the soil. But we don't think there's a lot of water in the topsoil on Mars, so that's a bit of a mystery how this all formed.
Yep, so we think potentially in the past the Perseverance Valley was formed by water, and so as we're going down, we're trying to find evidence of, was it carved by the wind, was it carved by water, what's going on? And I am also in the process of training to be a rover driver, and so just a couple weeks before this dust storm hit, I actually got to place the arm down on the surface and essentially brush the surface. So everyone's blaming me for the dust storm, that I was like brushing the surface and the whole butterfly effect and all that.
Exactly.
So it's all my fault. I'm sorry.
Yeah. Well, now before this happened, Opportunity was sort of taught a new trick.
Yep.
So let's take a look at that here. We can see in this slide, what are we looking at, and how was this image taken?
Yep. So the word selfie did not exist until after Opportunity already went to Mars. So we didn't exactly send a selfie-ready camera to Opportunity. But as we were coming up on Sol 5000, we knew that we wanted to do something special with the rover. You don't exactly hit Sol 5000 more than once. And, we wanted to do something special. And so we decided that we were going to do our very first selfie. Now, the camera that we took this with is a microscope, so it's really meant to be close to the ground, a couple millimeters away from the surface, taking high-resolution photos, and still black and white. So we really didn't know how it was going to look, but we thought we would try. And so I was the uplink lead on that day, and one of the rover drivers and one of our camera poles got together, figured out how to do the selfie, and that's what we sent to Mars. And we came into work the next day when the images were coming down, and we couldn't believe it actually worked, and how beautiful it looks, and that you can actually see the rover. And the most interesting thing that we noticed was that there's kind of a necklace almost around her neck there, a little bright strip, and we were wondering what in the world that was. And so we went back to photos of it in the clean room. Turns out that's a strip of Kapton tape that apparently the dust doesn't cling to. She's very dusty otherwise, but she's got her little necklace, so I kind of like that.
That's very nice indeed, yeah. Now, I noticed another picture where she had reached a very steep slope in the valley she's in, and some dust actually was cascading on the solar panels. So is that a way to maybe clean the solar panels, park on a really steep slope? Would that work?
So actually in Perseverance Valley, we actually got some wind cleaning events not too long before the dust storm. Essentially, we were parked up on a little tiny ridge, and it just must have lined up with the wind patterns. And within a few sols, we went from about 50% of our solar panels clean to 90% clean.
Wow.
We had a huge jump in power available, and so that actually helped us prepare to go into this dust storm, was getting that nice cleaning event a couple weeks beforehand. So that was kind of a fortunate event, and we actually see this continually on Mars. Is every once in a while the winds come and they just blow all the dust right off.
Yeah. So this is really amazing. So Opportunity was sent to Mars at the last close approach. And here we are 15 years later, and we're hoping Opportunity will come back and talk to us again. So amazing mission, certainly groundbreaking, and we learned so much about Mars, and it kind of laid the groundwork for the next rover we're going to talk about, because Mars, of course, has more than just Opportunity on the surface. There's also a rover named Curiosity. So what can you tell me about Curiosity, and what year did we send it, and how is it different than Opportunity?
Sure. Curiosity is now 6 years on Mars. It launched in November of 2011 and landed in August of 2012. And it was designed to last about 2 years on the surface of Mars, and now it's been 6, so not quite as old as Opportunity yet, but we're getting there. It's no longer a spring chicken anyway.
Exactly. Now, what was Curiosity's mission?
Yeah, Curiosity's mission built on all the discoveries from Spirit and Opportunity. As Keri said, Spirit and Opportunity were really focused around looking for water on the surface of Mars. Really, finding evidence that water was persistent and flowing on the surface. Curiosity looks for water as well, but also the other elements of habitability. So you can see on this chart, we break down what it takes to support life on Earth. You need liquid water. That's kind of a common denominator for all sorts of life. You need key chemical ingredients, the stuff our cells are made out of, the carbon, the nitrogen, the oxygen, the hydrogen, sulfur, all that. And you need sources of energy, whether it's sunlight or something else that microbes could live off of. So we have this big rover with 10 instruments and 2 laboratories that are built into the rover itself, and a big drill that drills into rocks and gets those that precious interior powder of the rocks into these laboratories to do these experiments. And that really is what Curiosity is all about.
Yeah, pretty amazing. The Curiosity, when it landed, it was sent to travel up a mountain called Mount Sharp in the middle of a crater. And that mountain was not the uplift from the formation of the crater, but rather was laid via deposits over time, and then the crater was excavated again via winds, we think. But Curiosity did not head right towards the mountain. It actually kind of drove the wrong way. Why is that when it got there? What inspired us to turn the different direction and seemingly go the wrong way?
Well, Curiosity's landing system was the most advanced of its time, but even with it, we had to pick a area that was safe over about 12 miles. So we didn't really know where we were going to end up. But we do have these fantastic maps of Gale Crater where we landed from orbit. And once we did know where we actually ended up the day of landing, we found that we were pretty close to what we thought from orbit might be evidence of an ancient lake bed. And what was upstream of that, what really was the evidence, there's a channel that comes down from the northern crater rim. It spreads a fan across the crater floor. And we realized that it's only a little bit to the left to go there, even though the rest of the mission was to the right. So we took a pretty momentous decision to not go straight to the mountain, but actually turn left and go see this ancient lake bed. It turned out to be where all the big discoveries of the mission were made in the first year on Mars. And so it was a great gamble that we took. And we spent about a year there, in fact.
Right.
And then we got antsy and decided we really need to head for the mountain.
Turn around and head to the mountain.
Yeah.
Now, this slide here you've brought to us, you say a river delta. So where did Curiosity actually see this river delta that you were talking about a little
This is one of my favorite images from the mission because it just shows so beautifully that we're standing in the middle of what once was an ancient river flowing into the screen here. We're looking sort of downstream. And when this river was carrying sand, it encountered a lake. And we're looking right where the shoreline of this lake was. And these tilted rocks that are in front of us are the sand that dropped out of the water as the water entered into the lake. And as you mentioned, what's not so obvious about this is that there's a mountain sitting where that lake should be. and so the history of Gale Crater that we've pieced together is that the crater was once empty, and there were rivers flowing into the crater, and the crater was slowly filling up with muddy water, and the mud settled out, and the sediment just filled the floor of the crater till it got as high as a mountain, and then wind has now carved most of that mud away and leaving a mound in the middle. So it's been a complicated, long history, but one that involves a lot of lakes.
It seems to. Now, what's shocking about that image is how much like Earth that looks like. Now, I know we've corrected the colors on this. If this were on Earth, this is what it would look like. It would be much pinker and redder and dustier looking if we were actually on Mars. But nonetheless, this looks like it could be a shot maybe in Death Valley or out in the Mojave somewhere. I mean, we have to remove any of the plants, but still, we're seeing a landscape a lot of people are sort of have familiarity with in a way. And is that because so much water was there, do you think?
Yeah, and it's also fundamentally just because Mars and Earth fundamentally are very similar, and that's what's been really striking to me is it's not like an alien world that you've never seen, purple rocks before or something, It's like you're out in the desert. It's like you're in an environment on Earth where it's very dry and arid, like Mars is, and where water and wind are doing most of the geology. And a lot of our geologists on Earth can recognize what they're seeing on Mars because they've seen it when they're out in the Mojave Desert, for example. Yeah.
So now the Murray Buttes on Mars, how did those get formed? And Curiosity visited here, I take it? We have a picture of it.
Yeah, I love this picture too. It's just Bugs Bunny and Roadrunner, you know, landscape
so.
here, and you could be in Utah, you know, in this picture, but we're on Mars, and what you're seeing on the floor of these of this picture is the Lakebed Rocks. These are the rocks that formed out of mud at the bottom of an ancient lake. After those lakes dried up, sand blew into the crater. And this whole scene that we're looking at was covered by 20, 30, 40 feet of sand that hardened into rock and now has mostly been eroded away, just leaving these little towers of sand overlying the lakebed deposits. So
the towers look like they're very layered. You can see horizontal layers in those. And those must have been laid down over a long period of time.
That's
It's
right.
that sort of layering we want to go look at on Mount Sharp to learn about the climate changes on Mars and those sorts of things. Have we learned anything about that so far?
We have, you know, we now have followed the river through the deltas into the lakes, and once we're at Mount Sharp, we're seeing that now over 1,000 vertical feet of this mountain it consists of little millimeter scale layers of ancient mud. So this mountain built up over eons as lake after lake and mud layer after mud layer piled on top of one another until you now have over 1,000 feet of that. So when we compare that to lakes on Earth, we get an age of at least 10, maybe tens of millions of years when this area was basically covered by lakes.
Okay, so it was a long time that it was covered, but this
Yeah.
was also a very long time ago.
Right.
That we think this was probably how long ago on Mars?
We know that the crater formed about 3.8 billion years ago, almost 4 billion years ago, and that Mount Sharp had completely formed and been eroded into its present shape by about 3 billion years ago. So everything that we've been studying happened sort of in between those two times, about maybe 3.5 billion years ago.
Okay, so if Mars was habitable, this was quite a long time ago.
Yeah.
And we're really looking for these clues that have been sitting buried for billions of years.
That's right.
And yet we're able to do this.
We are. You know, we can confidently do the geology on rocks that old because the rocks kind of last. What's a lot harder to do is look for the evidence of life. And
Right.
we don't necessarily look for evidence of life with curiosity, but we do look for things like organic molecules that are part of those
Right.
raw materials that life needs. And to find those, which we now have in multiple sites, is pretty remarkable when you think that they also have lasted now for 3.5 billion years on the surface.
Right. Now these organic molecules, this is recently there was a claim that Curiosity found some very complicated ones or complex ones that look similar to ones we see in deposits on Earth that come from like oil deposits that have broken down. Does this mean there's oil on Mars? Were there, ancient plants, and was this plant matter that was compacted and turned into? Is that the thinking?
I mean, what's fascinating is that is a possibility, but we can't.
But it's
see
not
that.
for sure yet.
It's not for sure.
Okay.
Yeah, what we do know is that we found little fragments of organic molecules that we think once fit together into these much larger and complex organic molecules, similar to the ones you're describing on Earth, where you have degraded plant matter or dinosaurs or whatever else that gets degraded into this organic goo. And we may be seeing that on Mars, but it's going to take a more sophisticated rover like the 2020 Mars rover to really figure out if it's actually evidence of life or just naturally occurring organic goo. That's another possibility on Mars.
Right. Okay. Now, in addition to these organics, Curiosity has seen methane
Right.
come and go, and it isn't just methane that shows up. It seems to be somewhat seasonal,
Yeah.
which is very interesting. Now, where could this methane be coming from?
Well, it's been a long story for us studying it. We first went to Mars with a little detector of methane that was added to Curiosity late in the game because telescopes on Earth found evidence of methane on Mars. So we added this detector, and we were the first mission to land on Mars and measure methane.
Now, I should add, methane's an interesting gas because it breaks down. It just doesn't hang
Right.
around in the atmosphere. If it's put into the atmosphere, it'll react rather quickly and be gone. So the fact we're seeing it means it has to be produced somehow.
That's right. The fact that the telescope saw it from Earth was remarkable because they saw plumes that came and went, and it shouldn't be doing that.
Right.
Methane gets degraded, as you're saying, so it should just be lasting, hundreds of years and not varying. when we landed, the story only got more complicated because we saw these little burps of methane that lasted just a few weeks and then they would go away. And to be honest, we still haven't explained those. But what we now have seen is that a more constant, not really constant, but a smaller background level of methane is also present when these burps aren't occurring. And that background level varies with a seasonal cycle. And we think that's coming from underground, from natural processes that produce methane in underground, and that the seasons on Mars determine how much gets in the atmosphere.
Okay. So it just could be something naturally occurring along the lines of volcanism or something like that buried on Mars.
Certain minerals degrade underground and release methane.
So I shouldn't get too excited and think this is bacteria producing methane on Mars.
Well, we're nice, skeptical scientists, but again, it really is fascinating that is a possible explanation.
Yeah, so we'll have to do a little more work. Now, of course, this ties into the recent announcement that Mars has a liquid water lake.
Right.
Now, this isn't on the surface, though. It's
this lake that was discovered from a radar instrument on a European spacecraft called Mars Express. They flew a radar across the planet. Those radar signals go deep into Mars, bounce back, and when they encounter something like liquid water, they send a very bright signal back. And they found a patch that's about 12 miles across, but a mile and a half underground.
Oh, so we can't send a rover there by any stretch.
But it really is. If this evidence holds up under further scrutiny, it would be the only liquid water that we know of on Mars today.
Pretty incredible.
Yeah.
It really is. So, well, what does the future hold? You mentioned another rover, Mars 2020. Are either of you hoping to work on that project, or what can you tell us about it?
So my favorite aspect of the 2020 mission so far is the fact they're also going to send a helicopter. And now my background's in meteorology, so the idea of getting to fly something through the atmosphere is pretty exciting.
Now how would a helicopter on Mars work? Mars's atmosphere is only 1% of Earth's, so a helicopter will really work?
Yeah, so we actually have a vacuum chamber at JPL that we've gotten down to Mars pressure with this helicopter in it and had it fly.
Wow.
Yeah, so anything's
pretty
possible
cool.
if you put enough engineering into
That's
it.
right.
Exactly.
Big blade spinning really fast and a very light helicopter.
A very light helicopter.
Yeah.
Well, that'll be neat once that makes it there. Now, that's more of a testing mission just to see if this will work and do some exploration with it.
Right.
The Mars 2020 rover itself, how is that going to get us closer to seeing whether Mars was once alive or maybe has signs of life now?
Yeah, so what's really been wonderful about NASA's Mars exploration program is one mission builds upon the other. So we went to Mars with orbiters, mapped the whole planet, figured out where to send these landers and rovers, and then we had a rover looking for signs of liquid water, Spirit and Opportunity in the past. We had Curiosity, expanding that for habitability, and then now we're going to actually directly look for signs of life with the 2020 rover in ancient rocks again. So when we think Mars was most likely to have life, it was at 3 to 4 billion years ago. They're going to look for chemical patterns, mineralogical patterns, structures, anything that might be evidence of life actually having taken hold on Mars.
Right. Well, the test is sort of, we know what happened on Earth, and the conditions on Mars seem to have been very similar to what Earth was like when life came about on Earth. So if it happened here, maybe it should have happened on Mars as well. So this is a fascinating thing to test, and it's the closest place we can go to make this test, which is just wonderful.
It is. What I think amazes me about what we've discovered with all these rovers is that, like you're saying, 3 to 4 billion years ago, Mars was even more Earth-like than Earth is today. So that's kind of fascinating to think about.
It's a little crazy. And then I just love the fact we've sent little rolling robots to Mars, and one of them has traveled more than a marathon. Opportunity is now at 28.06, something like that. It's over 28 miles.
Over 40 kilometers.
Over 40 kilometers.
Yeah, so,
Wow.
It's just nuts. And how far has Curiosity gone at this point?
We are now about 20 kilometers.
About 20 kilometers, which is just nuts. I mean,
Yeah.
Opportunity is driven further than the distance across Washington, D.C.,
Wow.
which is neat. So
Yeah.
they could drive that far, and Curiosity's in the bottom of a giant crater on Mars, looking for, and within its first year, accomplished its mission. It saw the elements that life needs. We know the energy source is there from the sun, and the signs that water was once present
right.
in large quantities.
Yeah.
And I've often heard that the water was something we could have drank. The pH levels and everything, back in the day, we could have got a scoop of it and perhaps just drank it.
Right.
Would you trust that? Would you take a drink of Mars water?
You know, where we first went to that place where we took the left turn, that place was called Yellowknife Bay, and I really think all that is accurate. As we've climbed the mountain, one of the reasons we climbed the mountain, in fact, was to see not just in one place, but layer after layer, how did the climate change? How did the water change? And we've actually seen the water get saltier, and so it's not going to be as tasty higher up on the mountain. Yeah.
Exactly. Yeah, very interesting. Well, thank you both for joining us tonight. It's a beautiful night here in Los Angeles, beautiful view of Mars, beautiful warm night here, and the fact we have rovers up there. And we're waiting to hear from Opportunity still, so we'll wait for these dust to die down, and then Curiosity's just working right through the dust. So,
That's right.
Thank you both for joining us tonight.
Thank you.
Thank
Really
you.
appreciate it.